All right, here we go on function inverses. So solving our exponential here, if we follow our arrow diagram method, that would say start with the t, divide by 5,600, stick that in the exponent of a 1/2, and multiply by 1,000. And we're supposed to get 2 at 200, so first step, divide by 1,000. Then we're going to do a log divided by the log of a 1/2. And then finally multiply by 5,600. So if we get the calculator out, it starts with a 200 divided by 1,000 is a 0.2. So we're going to do the log of the 0.2. and divide by the log of 1/2. And get that, and then multiply by 5,600, and the answer is about 13,003. So t approximately 13,003. All right, divide 2x minus 3 by x plus 4. We need an area model for that, so we're going to divide by the x plus 4. And trying to get a 2x minus 3 in the boxes combined together, so this would have to be a 2, and that would make that an 8. And we're already then building remainder. This was supposed to be a minus 3. It's an 8, so we would need a minus 11 there to make that come out to be a minus 3. So we get 2 minus 11 over x plus 4 as an answer when we divide those. All right. Let's see. Sketch graph of the inverse of the relation on the same graph. Okay. Well, we can do this. We can make a table to help us out here. This function has the points -2, -1, and then it looks like -2, 2 is on there, and then it goes down to 0, 1, and from there to 1, 2, and then to 2, 0. And so if this is the function, then its inverse will be exactly the opposites of those. So we just switch the x's and y's. The -1 now goes to the -2. The 2 goes to the -2. 1 goes to 0. 2 goes to 1. 0 goes to 2. And we'll plot those points. -1, -2. is right there, and 2, -2 is right there, and we'll connect those. And then to 1, 0, which is right there, so we'll make that connection without that stray extra line in there. And then to 2, 1, 2, 1 is right there. That'll come up there, and to 0, 2, right there. Okay. So that is the inverse of the one that we were given. Okay. All right, if f of x is 2x minus 7, then what is f inverse? One quick easy way to do this is to build the arrow diagram. So we'll multiply by 2 and subtract 7, and then we switch x over to here and go back, which is adding 7 and dividing by 2. So x plus 7 divided all by 2, that is f inverse. Okay. We can build inverse the same way. With this, it's a little bit more complicated, more things going on, but it's just more arrows. So we start with subtracting a 5, then we divide by 12. We stick that in the power of the 1.006, and then we multiply by 3. And so we switch the x over to this side, and we will divide by 3. And then we'll go ahead and write this one as a log base 1.006, multiply by 12, and add 5. We know that we could write that as that, or we could do it as log of divided by the log of 1.006. Could do that either way. So to start with the x, divided by 3, put that into a log base 1.006, multiply that by 12 and add 5. That is the inverse function right there. Okay. Put some boxes around these other things for later. Okay. All right. Verify that these are inverses by simplifying h of g of x and g of h of x. So h of g of x says do the g first. We know that the result of our g arrow will be an 11 over 2 minus x. And this on your worksheet is not a plus 4, it's a minus 4, and it should be a minus 4. So that's what's going to come out of g. And then out of h, we're going to, that's a little bit tough one to represent on an arrow diagram. The only option we have is this. So this goes into both of those blanks. That gives us a 2. And inside the blank we have an 11 over 2 minus x minus 4 minus 3. So there's the 2 times x minus 3, where the x is this whole thing, divided by the 11 over 2 minus x minus 4 plus 4. Okay. And we need to simplify this. On the bottom we pretty quickly get an 11 over 2 minus x. In the numerator, I'm going to get a 22 over 2 minus x minus 8 minus 3. And that is going to simplify in the numerator to, obviously this is going to be a minus 11. If I found a common denominator there of 2 minus x, that'd be, I'd have to multiply this by 2 minus x over 2 minus x to make that happen, which would give me a 22 minus 22 plus 11x over 2 minus x over 11 over 2 minus x. Those cancel. I have an 11x over 2 minus x divided by this, which is times the reciprocal of that. And the 2 minus x's cancel, the 11's cancel, and all I have left is an x. Okay, so this is that first one, h circle g of x, gave me an x. To verify this inverse, I need to do it the other way as well. That's going to look like an 11 over 2 minus all of this h stuff, the 2x minus 3 over x plus 4, minus 4. From that, I'm going to have to do the common denominator business down here and multiply this by x plus 4 over x plus 4. And that will give me an 11 over 2x plus 8 over x plus 4 minus 2x plus 3 over x plus 4, all with a minus 4 on the outside. Okay. distributed the negative through there like I was supposed to, so this is a plus and a negative there. Those are going to cancel. The 8 plus 3, this is going to give me an 11 over x plus 4 minus 4, but that is an 11 times x plus 4 over 11 minus 4, and those 11s will cancel, and the x plus 4 minus 4 will leave me just an x on that end, just like I did on that version. So that verifies that those are inverses. That's about as rough an inverse verification as you're going to come across. Okay, working with those same things, we are going to take a look at the graphs of both of these functions. Okay, so the h of x, the 2x minus 3 over x plus 4, that's in red, and the other one is in blue. It says, comment on the relationships between the vertical asymptotes and the end behavior that you observe. Okay, well, the red one, I'll draw these in here. The end behavior is for h of x. The end behavior is that as x approaches either positive or negative infinity, h of x is approaching 2. And it has a vertical asymptote at negative 4, at x equals negative 4. Okay. For g of x, if I take a look at what's going on with my g of x, it has a vertical asymptote at x equals 2, and its end behavior is that as x goes to either positive or negative infinity, g of x is going to negative 4. So it has a horizontal asymptote at negative 4. H of x had a vertical asymptote at negative 4. H of x had a horizontal asymptote at negative 2. Let me go back now that I've drawn this and recorded the information that I have here. So the horizontal asymptote of h of x is in the same place as the vertical asymptote. So horizontals become verticals, verticals become horizontals. These things traded places even in the vertical asymptote for horizontal asymptote. Domain and range switched places on those if I wanted to take a look at that graph there. Okay, I can see that the domain and range have actually switched as well. So the domain of my h of x was that x could not equal negative 4. Well, the range of the g of x was that y could not equal negative 4. And the domain of g of x was that x could not equal 2. And the range of the h of x was that y could not equal negative 2. So consistent with all of that swapping. In fact, if I looked here real quick at g of h of x, I see that I get the line y equals x, which is characteristic of inverse functions as well. Okay. So jumping back in there, I believe we are done with that one.